Okay, in this video what we're going to do is we're going to talk about how we graph an equation when it's given to us in two different forms. And then we'll bring up the concept or the conversation of domain and range again. But we've covered that pretty sufficiently inside of our previous videos for section 2.3b. So we'll just kind of touch on it real quickly as we're working. So the first thing is that we have two types of forms of our equation. We have what's called slope-intercept form. And in slope-intercept form, we have two special numbers here. We have the m, which is called our slope. So our slope is the number that's in front of the x. And then we have our b, which is called our y-intercept. And in this case, our b will always be by itself. It won't have a variable by it. So like whereas slope will have the x, our b will just be by itself. So when we take a look at this equation right here, we can see that our slope is 2 and our y-intercept is -3. And so at this point, we can say, okay, well, if I wanted to graph this, we've got a process. So you're going to use your tools inside of my math lab. But I'm just going to draw a rough sketch. This is my x-axis. That's my y-axis. This is my x. Put a couple lines on here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we start off, and the first thing that we're going to do is we'll plot our y-intercept. So we'll go to -3 on the y-axis, and we'll draw that spot right there. So that's my y-intercept at b equals -3. Now we need our slope. Well, previously on our previous slide, we learned that slope is rise over run. And we calculated our slope, but we didn't talk about how to use that slope. So in this case here, this number can be converted to 2 over 1. So therefore we have a rise on top and a run on the bottom. So when I come from this, so our step number 2, is to find additional points using the slope. So what does that mean? Well, that means that we come from our y-intercept and we rise 2. So we rise 1, 2, and we run 1. So we have our rise over our run. So we have a new spot right there. We do it again. We rise 1, 2, we run 1. We can do it again. We rise 1, 2, we run 1. Then we come with our straight edge, or in the case when you're doing this inside of my math lab, you'll have the straight edge tool there. But then at this point, I would come with my straight edge and I would connect my dots. And that's what my line would look like. That's the slope of a line that crosses the y-axis at -3 and has a slope of 2, or 2 over 1. When we come to the next equation, there are several ways that we could do this, and if you look real closely or you dig real deeply inside of my math lab, you might have a video where they would show you how to do this with a table, or they might show you how to do this with intercepts, because we've talked about intercepts in the past and we will more in the future. But I'm going to go with one route. And the route I'm going to go with is I'm going to put this equation into slope-intercept form. So my first thing on this guy is I'm going to put into slope-intercept form. So I'm going to take this equation right here. I'm going to move my 2x. Remember, slope-intercept form is y equals mx plus b, slope-intercept form. So I move those over, the 2x's cancel. I'm left with -5y is equal to a -2x plus 20. They're not like terms, I can't put them together, so I put them side by side. I would divide by -5, divide by -5, divide by -5. I divide everybody by -5. My -5's cancel. I get y is equal to a positive 2 over 5x minus 4. Because a negative and a negative equals a positive, and a positive and a negative equals a negative. So from this spot right now, I can identify my slope as 2 over 5 and my y-intercept as -4. So I can come down here and I can go ahead and draw a quick sketch. So this is my X, this is my Y, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I start off, I plot my y-intercept, that's at -4. I find additional points using my slope, so I go up 1, 2, over 1, 2, 3, 4, 5. I'll add some other lines on here. 1, 2, 3, 4, 5. And so I can do this again. I can rise 1, 2. I can run 1, 2, 3, 4, 5. So now I have enough points. I mean, 2 points is really all that I need. But now I have enough points that I can come across right here with a straight edge or my line tool. And I can connect the dots and find my graph. All right, so last thing for this slide is to talk about the domain and range. Let me grab my right tools. And let's go black. All right, so domain and range. Well, this is a linear function. This is a polynomial function, which you're going to hear me talk about that more in the future. So both of these graphs, the domain is going to be all real numbers because you can plug in any x. There's no limitations. There are no limitations on x. There's nothing that x cannot be. This graph continues in both directions. Even though this one is going up very quickly and down very quickly, it's also continually going out in the negative direction. Same thing here. Even though this is going up very quickly, it's also going out in the positive direction. This graph is the other way around. It goes up slowly and goes down slowly and goes out in the negative direction quickly or out in the positive direction quickly. But still, the domain is all real numbers. The range, same concept, same idea, is going to be all real numbers. This one goes to negative infinity very quickly. This one goes to positive infinity very quickly. This one takes a little bit more time. So my domain and range for both of these will be all real numbers. All right, so that takes a look at using the equation of a line to be able to find the slope and the y-intercept, which leads us to being able to graph. So give me 1 second. And we'll wrap up right there with that video, and we'll just call that, graphing using slope and y-intercept, and then we'll look at a video for special graphs.